A quadratic function is a polynomial function of degree 2. Recall from section 1.3 that the graph of a squared function x squared is a parabola. We will see that the graph of every quadratic function is an upward or downward opening parabola. This is because the graph of any quadratic function can be obtained from the graph of x squared by a sequence of translations, reflections, stretches, and shrinks, which is things we went over in example in section 1.6. Now, if we look at example 4, describe how to transform the graph of y equals x squared into the graph of the given function. Well, we should see that the positive 1/2 is a vertical shrink by a factor of 1/2. We should then also see that the negative out front is a reflection over the x-axis. Then we'll also see that this plus 3 is a shift up of 3. So if we take a look at our graphs then, we have x squared, then we have negative 1/2 x squared plus 3. Oops. I thought I went down enough. So there is x squared, and there is the negative 1/2 x squared plus 3. Now, in the next one, you should see that the 3 is a vertical stretch by a factor of 3. And we're going to shift left 2 because there's a plus 2 in there. Then we're also going to shift down 1. Now, if you put that in your calculator, and there you have it right there. Now, remember with the vertical stretch, we are taking all of our y values and stretching them by 3. So we're multiplying all of our y values by 3. Now the graph of f of x equals ax squared, where a is greater than 0 or positive, is an upward opening parabola. When a is negative, it's a downward opening parabola. Regardless of the sign of a, the y-axis would be the line of symmetry for ax squared. Now that doesn't take into account any shifts left, right, up, or down. Now the line of symmetry for a parabola is called its axis of symmetry, or axis for short. The point on the parabola that intersects its axis is the vertex of the parabola. Because the graph of quadratic function is always an upward or downward opening parabola, its vertex is always the lowest or the highest point of the parabola. Now you can see here, the vertex of ax squared is always the origin if you have ax squared. That, again, that's if you're not shifting it left and right or up and down. Now, if we look at the standard equation for a parabola, a times x minus h squared plus k, and comparing the resultant coefficients with the standard equation ax squared plus bx plus c, where the powers of x are arranged in descending order, we can obtain formulas for h and k. This is what's known as the vertex form of a parabola, because we can find the vertex fairly quickly from it. So if we take a look at a times x minus h squared plus k, and then expand the x minus h squared to x squared minus 2hx plus h squared, then we multiply the a in, we'll have ax squared plus negative 2ahx plus ah squared plus k. And if you look at it, b will actually be negative 2AH, and C will be AH squared plus K. Which means if we had to solve for H, which would be the x-coordinate of the vertex, H will be negative B over 2A. We can see that right here. Solve that for H, you get negative B over 2A. And then K will be C minus AH squared. Now, using those formulas, any quadratic function can be written in the form A times x minus h squared plus K. Again, it's called the vertex form. The parts that I need you guys to remember are generally these. We're going to be using these formulas quite a bit. And again, what we have below here is pictures of the parabola shifted left and right, up and down. Now the formula h equals negative b over 2a is useful for locating the vertex and axis of the parabola associated with the quadratic function. To help you remember it, notice that negative b over 2a is a part of the quadratic formula if you cover the radical term. Right there. You don't need to remember that k is equal to c minus h squared because you could use k equals f of h instead. Let's look at example 5. Now, we know that a goes with the x squared term, b goes with the x term, and c is the constant term. So, because we're looking for h is negative b over 2a, we got to find the vertex. Well, first we got to write the function in vertex form. So, if we have to find negative b over 2a, we'll have a negative 6 over 2 times negative 3. That will give us negative 6 over negative 6, which is 1. Now, to find k, we could do it a couple different ways. I'm going to use f of 1 because the direction said we could use this right here, f of h. So I'm going to find f of 1. That'll be negative 3 times 1 squared plus 6 times 1 minus 5. So that'll be negative 3 plus 6, which is 3 minus 5 is negative 2. So my vertex will be 1, negative 2. My axis of symmetry, or my axis, will be the line x equals 1. And if I wanted to put this into vertex form, we'll have to solve that algebraically, which really isn't too hard, but we can get into that once we get into example 6. So let's graph this equation. So negative 3x squared plus 6x minus 5. Now you should know that this graph will open down. It's a parabola that opens down. So graph it here. And if we look, let's look for our vertex, value of 1, negative 2. That is the highest point on our parabola. So that would be our vertex. Again, once we talk about example 6 in class, I will talk about how to put things into vertex form straight from the graph. Moving on to B, our A value is 2, our B value is negative 7, our C value is 3. So to find the vertex, again, it's negative B over 2A. So actually be a positive 7 over 4. Our K value will be f of 7 over 4. So 2 times 7 over 4 squared minus 7 times 7 over 4 plus 3. Simplifying this, we'll have 2 times 49 over 16 minus 49 over 4 plus 3. So it really would be 49 over 8 minus 49 over 4 plus 3. Now I don't want to do any more fraction work. So I'm actually just going to put this into our calculator. And then math, enter, enter. That'll change it to a fraction, be negative 25 over 8. So that means my vertex will be 7 over 4 and negative 25 over 8. My axis of symmetry, or my axis, will be x equals 7 over 4.